Okay, so let's look at doing some fractions to percentages. I'll just pull up what I've got here in type maths. So I'm going to work through 5 examples and have a look at them. So the first thing we're going to do in this one, we're going to turn the fraction 2 over 10 into a percentage. We're going to divide top and bottom by 2 to simplify to be 1/5. Now 1/5 we can think of as 1 divided by 5. Now, I happen to know off the top of my head that 1/5 is going to be 0.2, but let's just have a look at how to work that out the long-winded way. Um, Basically, 1 divided by 5 is the same thing as 5 into 1. And this is counterintuitive because 5 is bigger than 1. So immediately we hit a stumbling block. We say, well, how many times does 5 go into 1? Well, it doesn't. Okay, well, we could say remainder 5, but we're not actually going to do that. What we're going to do instead is we're going to add a decimal and a 0, and now we're going to go 5 into 10. And 5 goes into 10 2 times, so we have no remainder, and so we get 0.2. And so this tells us, in fact, that the remainder, when we work out 1/5, sorry, the decimal is going to be 0.2. Now, when we convert 0.2 to a percentage, we can think of it like we're multiplying by 100%, right? Because 100% is actually just 1. But basically, if we do 0.2 times 100, we're going to get 20, and we keep the percent on the end. So we've multiplied 0.2 by 100 and added a percent sign, and so we get 20%. All right, let's go for the next one, 6 over 40. So just like the last one, you'll probably notice that we can simplify this, and we should if we can, because that'll make our life a bit easier. So we're going to get 3 over 20. Now, if we didn't simplify it, we could still answer the question. It just wouldn't be so easy. So 3 over 20 becomes 3 divided by 20, which we can now switch back, and we can say 3 divided by 20 is 20 into 3. All right, same sort of problem here. 20 is too big. So 20 goes into 3 no times. But we're going to add that decimal point and a 0. Now we go 20 into 30. Well, 20 goes into 30 once with a remainder of 10. We're going to add another 0, and we're going to put that little remainder of 10 there. So now we do 20 into 100, which is 5 times. So 3 divided by 20 is 0.15. So let me just pull that up here. 3 divided by 20 is 0.15. Now, we want to do that times 100%, and so that's actually going to give us 15%, right? So we do 0.15 times 100, add the percent sign, we get 15%. So you're probably noticing that that last step of multiplying by 100 is the same. So I want you to look for the things that are the same. So we're simplifying, we're rewriting it as a division, we're doing the division algorithm to get a decimal, and then we're multiplying by 100 and putting a percent sign at the end. So let's have a look at this one. Now this one, we actually don't need to simplify at all. So I'm just going to write it straight away as 7 divided by 6. Now 7 divided by 6 is a little bit different to the ones we've done before, because at least now we have a bigger number divided by a smaller number. So that means that we're going to do 6 into 7. Now, 6 goes into 7 once, but it's got a remainder. It's got a remainder of 1. So we're going to add a decimal point and a 0. We'll put the decimal point on top as well. 6 goes into 70, 66 times. Hold on. We went into 7 once, and then there was a remainder of 1. Whew, almost forgot to carry my 1. Don't make my mistake. All right, 6 goes into 10 once, and then there's a remainder of 4. So we're going to add a 0, put a 4. 6 goes into 45 times. No, 6 times 36 with the remainder of 4. 6 goes into 46 times 36 with the remainder of 4. Oh, there's a pattern here. This is going to be 1.16, and then we put a dot above that second 6. That doesn't look like it's above the 6 at all. A dot above the second 6 tells us that that 6 repeats forever. So if we switch back now to type maths, we can say, well, that is 1.16 ... repeater. I don't know how to put a dot above a letter in type math. That's one or above a number. It's one of the only things I don't know how to do with it. Now, if we have this, I'm just going to round it, and then we say times 100%. If we know how to spell times. Boy, making mistakes everywhere. So that's going to give us, move the decimal point 2 places over, 116.7%. All right, so I hope you understand what I've done in the last part there. Again, you can go back and look at the previous ones. You're looking for what's the same. Now I've got 2 more that I'm going to do. 15 over 4. So 15 over 4 is not something we can simplify, so we can just think of it straight away as 15 divided by 4. So let's go back to our notebook, and we'll say 15 divided by 4. Well, that's 4 into 15. 4 goes into 1 0 times, 4 goes into 15 3 times, with a remainder of 3. So we're going to add a 0 and put our remainder. 4 goes into 37 times, with a remainder of 2. So add our 0 and put a 2 there. 4 goes into 25 times and no remainder. So we're done. So 15 divided by 4 is 3.75. And, you know, if we have 15 over 4, that's actually the same as 3 3/4. So it shouldn't surprise you too much, because this is the same thing as 3.75. Okay, so going back to type maths here, this here is our 3.75, and we want to turn that into a percentage, so we're going to multiply it by 100 and put a percent sign at the end, and so that's going to be, 375%. All right, last but not least, 8 over 7. I've chosen this one because fractions over 7 are a little bit more work than a lot of other things are. So what we're going to have to do first is rewrite this as 8 divided by 7. And then we're going to go put it into our division algorithm back over here. So we can say, here, I'm kind of in the way. Let me move myself out of the way. We can say 8 divided by 7 is equal to 7 into 8. So 7 goes into 8 once with a remainder of 1. 7 goes into, put the decimal above and below. 7 goes into 10 once with a remainder of 3. 7 goes into 34 times with a remainder of 2. 7 goes into 22 times with a remainder of 6. 7 goes into 60. Oh, can you beat me to it? 56 times. Sorry, 56, which is 8 times with a remainder of 4. 7 goes into 45 times with a remainder of 5. 7 goes into 57 times with a remainder of 1. 7 goes into 10 once with a remainder of 3. And in fact, you'll be able to see here, let me move my cloud out of the way, that we're actually beginning to repeat here. So we can put a dot over the 1 and the 7, and that tells us that this is what is repeating. Whoops, didn't mean to cut it up with my pen like that. Anyway, if we switch back, we basically get that 8 divided by 7 is 1.142857, and then this part here is going to repeat. So I'm just going to write it without the repeat dots, the dots above the 1 and the 7. I'm going to write it without that because I don't know how to type it on type maths. I suppose I could do, maybe I could do like quote marks so you can see that that part is what's repeating. And then when we multiply by 100, that essentially tells us that that decimal point is going to move across 2 spots and I'm going to round. Let's just make this 114.29, and so we get 114.29.29%. So here we've done some simple ones that involved simplification and division. We've done this one also, just simplification and division. This one here was a bit more work. We had an improper fraction, so we got an answer that was greater than 1, or in other words, over 100%. Okay, and it had a repeating number, so maybe I can write the repeating number like that. You know, that dash, I'll put it around the 6, so it basically says the 6 is what's repeating. If you remember, the proper way to do the notation is just to put a single dot above the 6. And then this one, again, was an improper fraction. So 15 over 4 is actually equal to 3 3/4. So it makes sense that we got 3.75, and then that's 375%. And then finally, 8 over 7. 7's a real pain because we get this really long repeater. But if you practice a bunch of 7s, you'll actually learn that there's a really nice, easy pattern to it. And if you remember the pattern, then you can save yourself a lot of work. And then, of course, multiplying by 100 just moves the decimal point across, and that's how we get the percentage. In every case, we just multiply the decimal by 100 and add a percent sign. The tricky part is getting from the fraction to the division to the decimal, right? And it's easy on a question like this, and it's much harder on a question like this. And in each case, what we've done to get there is we've taken the fraction, rewritten it as a division question, and done the division like this. So I'm trying to explain it really thoroughly. If you can have any specific questions to ask me, just let me know. But this should give you a really broad overview of how to turn a fraction to a percentage by turning it to a decimal in between. All right. Well, I hope it helped.